Well, welcome everybody to the Button Up Workshop that Andy Duncan, who is the Energy Director, is that correct?
Training Coordinator.
The Energy Training Coordinator at Lakes Region Community College will be leading tonight. I am Dory Drachman. I am one of the coordinators for the Peterborough Renewable Energy Project, or PREP. Bob Herring-Smith is the other coordinator. And we have been working with the town very closely to work on all kinds of measures that will help us transition to 100% renewable energy by 2050. One of our more exciting pieces that we've been working on is a program to help people transition away from fossil fuel heating systems to highly efficient cold climate heat pumps. And in conjunction with that, if any of you have gotten any kind of work done on your house, you will know that we have very few contractors in the area to be able to do that kind of work. And so one of the priorities for PREP has been to increase the workforce on in the energy area specifically. So we've been offering some courses and will continue to be able to increase the number of energy auditors, building analysts, and weatherization specialists, and also to bring in more heat pump installers. And we were really honored that this week we had that program highlighted on NHPR. I wanted to also just let you know about a couple of other programs that PREP is doing coming up in the next month or so, and an exciting program that's happening throughout Peterborough as well. One of them is to help your neighbors, if you are interested, to make this transition to 100% renewable heating and appliances. There is a program that Rewiring America, a nationwide organization that is championing electrification of all of our homes, and they've got an electric coach training. You do not need any prior experience in order to be able to do this training, and you can be doing it at whatever level you feel comfortable with. All it is helping people who feel stuck in their transition to mainly to cold climate heat pumps. How to do that, how to make that transition. Patsy told me about somebody who's been working in this climate arena for years, who was so flummoxed by it that he was planning on possibly getting another oil boiler instead of going to heat pumps. And so we want to make sure that people like him who really want to do this, and you guys who really want to do this, have somebody who could talk to you about it and hold your hand while you're going through it and help you make intelligent decisions. So we are organizing a cohort in Peterborough, but also beyond, to be able to help your neighbors that want to do this work but don't know how to proceed, to help them do it. And so we've got cards out there to tell you how you can register, and then how you can work with us to be able to get matched with someone who might want some help. The other program that's going to be coming up, and the next cohort for this training, it starts on May 23rd, and it is free. So it's once a week for about 2.5 hours, and then you can start helping people out. The other program that we are going to be doing in May is a climate cafe, which has become a really important movement in the country around climate, where it's a safe place actually for people to be able to talk about their feelings about climate. It's been kind of a taboo subject to be talking about how scared we might be, or how much grief we might feel, or anger we might feel at what is going on. So we are going to be holding a climate cafe in May. It is being organized by high school senior Lisa Petroff, and she's been working with the organizer of the Keene Climate Cafes, Matt Bolton. And they're going to be leading this first Climate Cafe. It'll be in the library on May 22nd, which is a Wednesday, up in the 1833 room. So those are the prep events that I wanted to tell you about. And then I also wanted to let you know about a program that is being pushed out town-wide. It is, we've got one of the organizers right here, Ann Fisher, who is organizing a program called Window Dressers, which is actually an organization in Maine, and they work with communities to build window inserts that are able to make your windows much less leaky, and they fit really well. It takes a huge effort to make the inserts, and then it also takes an effort to find the people who need these inserts. So the organization is looking for people to do both, to both sign up to help make the inserts and to sign up if you feel like your home has really drafty windows, to sign up to see if this would be a good fit for your windows. And does this have a way to sign up on here?
There's an email address.
There's an email address, thank you, you told me that. There's an email address that Ann actually wrote in, and we've got more of these on the table outside if you are interested in either aspect of it. Is there anything else you'd like to add about that?
It's covering all the towns of the Conval and Jaffrey Ridge School District.
Oh, that is really good to know, I didn't realize that. Great.
And the other key is 25 to 30% of the inserts are going to low-income people. And they'll either be free or just by donation.
Excellent, excellent.
So I have one quick question. How do you make those things?
Come to Matt's Makerspace and find out.
Okay, I mean, do you have to be handy?
No, they're laser measured here by a volunteer team, and then the measurements get sent to Maine, to where the organization is.
So you make the measurements in the window?
We make the measurements in the window, so they're really precise, and then they're, the wood parts come in pieces, all ready to go, and then we assemble them here. And that'll happen at Makerspace.
Wow.
Well, thank you for spearheading that.
So my name's Andy Duncan, as you heard. Phil Lamoureux is in the gray shirt in the back.
And I'm a former victim of Andy's former workforce development as well. I'm a building analyst that Andy certified several years ago too. So
yeah, that seems like a long time ago now.
It was.
But Phil's at Eversource Residential Energy Efficiency. So particularly when we get to the end of the presentation, and where we're talking about different programs that New Hampshire Saves has, particularly the Home Energy Performance Program, Phil's the person to talk with to find out how you can get eligible for that and other programs. So this is a program that's sponsored by the New Hampshire Saves Utilities. So in addition to Eversource, it includes Liberty, as well as New Hampshire Electric Co-op, as well as Unitil. I'm assuming everybody here gets their power lines at least through Eversource and not through another electric utility. Yeah. And the only natural gas around here is actually kind of a strange hybrid natural gas in Keene that gets trucked in, and then there's like this little mini pipeline that's actually a Liberty program. But I'm assuming most everybody's from Peterborough or the area here and not from Keene.
Eversource.
Okay, so we won't talk too much about natural gas. Next slide. And this is the abbreviated program. So I think we're going to go to, roughly speaking, with questions and answers till 8, something like that.
Yeah.
So we should be good. So I just want to let you know that these button-ups are coordinated by the Plymouth Area Renewable Initiative, another interesting group out of Plymouth rather than Peterborough. But they have a website, a web link where you can get a PDF of the slides. And Dory, did you know, did that go out as like an email for people who confirmed or anything? Or Bob, do you know?
Did what go out?
The link,
The link.
PDF.
I don't think that did, but we have their email addresses, and so we can send them.
Okay.
Yeah.
So if those of you are following along, it's the full version, which is a little bit longer than this one, but if you want something as a reference, nice to have.
Yes.
So we're going to talk about just kind of quick energy saving tips for the first part, and then get into what we call the insulation and air sealing ABCs. Remember the radio story with the drafty houses around here? There are a lot of drafty houses around here, which means we need to do a lot of air sealing. And so kind of talk about what does that mean in terms of whether you want to do it on your own or hiring a professional. New Hampshire Saves getting involved. And then the last part, like I mentioned, is the New Hampshire Saves programs that Phil can answer questions about. And I think we're not getting kicked out of here anytime real 8 o'clock sharp or anything like that. So
No.
if you've got like a longer question about your house and what you should do, Phil or I would be glad to answer that afterwards. If it's kind of a question related to the slides, feel free to raise your hand. And then the same thing with those of you who are on Zoom. Bob will be monitoring the chat for questions, so feel free to kind of do questions all along. Question already? All right.
Okay.
Good modeling.
Something we did two years ago, we,
That's sounding like an after the presentation
Yeah.
question.
Yes.
So I want to kind of move along.
okay, no, but I just wanted to say about fireplaces.
Okay.
We sealed our fireplace, and that was a great source.
Yes, there will be we've got a slide about that. So that's a good segue into the next slide here. So if you're thinking about like, well, you know, that electric bill, it's $100 a month, or, you know, maybe even more than that, it's like, where's it all going? I can't tell you specifically. Phil could give you some more hints, but this is just kind of a rough idea. And you know, the interesting thing is, you know, we have Phil from Eversource, the electric company, and we're both here to tell you how to use less electricity. So, you know, people kind of have a hard time with that, but there's actually state laws and other programs that encourage Eversource to invest in megawatts rather than megawatts. And that's all about what Eversource and New Hampshire Saves Energy Efficiency does.
Interestingly, we're not allowed to use energy efficiency money to incentivize converting from fossil fuel sources to electric sources. So we are absent from that electrification because it's not in state policy. There's a lot that other states are doing, but
so if you're already using electricity, help use less. But yeah, there's enabling legislation in other states, hint, that is not existent
decarbonization
in New
goals.
Hampshire right now.
Yeah, right.
Neighboring states.
Yeah.
That's why.
So before we move on, I see electric water heater is the top of the list here. If you switch to a heat pump water heater, what
Yeah, so we'll talk about that in a little bit.
Okay.
You know, I don't know exactly what the numbers would look like. You know, these are some pretty rough numbers. But if you're thinking about where's all that electricity going that's on your bill, if you're using electric hot water or electricity to heat your hot water, whether it's heat pump or what we call resistive heat, it's going to be a bigger electric bill than if you're using oil or propane or something else. So that's going to be a factor. I wouldn't be surprised if that number would be like cut in half with a heat pump hot water.
Third. I'm taking the coaching class that we were talking about.
Ah, a third. That sounds even better. Yeah.
The energy factor for some new heat pump water heaters is up to 4.
Yeah.
So that's 400%.
Yeah, so that's a good way to think about it.
Yeah.
Is that 300, 400% for every unit of electricity, you're getting in essence 3 units of hot water or 4 units of hot water versus resistive heat. Every unit of electricity, you're just getting 1 unit of hot water. And we will talk a little bit about heat pump hot waters, hot water heaters, as well as heat pumps.
And
a little bit
soon
later
Prep
on.
will be able to help you afford that.
Good. Yeah, and I've got some information towards the end of the slides about both the federal incentives, New Hampshire Saves incentives, and then on top top of all that, the prep incentive. So you've got like a triple whammy here in Peterborough with incentives to help with things like
A
that.
good whammy.
Yes, a good whammy. So another one that a lot of people don't think about that much is dehumidifiers. And think of those in your basement, if you have one, as like a window air conditioner. That's essentially kind of what it is, a little bit different. So when they're on, they use a lot of electricity. And that's another factor.
Wow.
This time of year, days like today, hopefully you won't need to have them on at all. Try to have them on as little as possible. Maybe get a little $10 humidity meter to determine when you should be kind of cutting it off versus on. You don't need to dehumidify the world, you just kind of need to dehumidify the basement to a reasonable level. And we'll talk about a couple other things here, but just kind of giving you an overview of kind of major uses of electricity. We've actually cut down the number for lighting because so many people are using these LED light bulbs now compared to incandescent. And they're even much more energy saving than a compact fluorescent, the squiggly ones. But if you've got those, I would recommend continue to use them. And once they wear out, save them for a household hazardous waste day, which I assume you folks have in Peterborough and other towns.
And we can also bring our
Yeah, we can read those.
our compact fluorescents to the recycling center.
Good to know. Next slide. So if you're kind of wondering, well, how do I know how much these different devices are using? And refrigerators is another good example that uses a lot of electricity, but some refrigerators use a lot less than other refrigerators. Do you folks know if the library here has these watt meters available to check out?
Don't know.
Be a good prep activity just to find out. So anything that's like plugs into a regular outlet, and there's different brands out there, that's one. They're like $25 or $30. And a number of years ago, like 15 years ago, every public library in the state got one or two of these. And a lot of libraries still have them. And so you just check them out like a book, and you can go around to different devices, plug it in, maybe leave it in for a day or so, and find out, over the course of a day, how much is that refrigerator using, for example, and then do a little math to get that equivalent in kilowatt hours for the whole year. And that's what you build in is a kilowatt hour. So that's 1,000 watts of electricity on for an hour. So if you had a light bulb and it's not on, it's not using any electricity. So there's a kind of a time aspect with electrical consumption. 1,000 watts for an hour is a kilowatt hour. And around here, it's what, about 20, if you can include all the costs. You folks have community power now, right?
Yeah.
So you have to kind of include the keeping the lines up as well as the supply cost. But if you add that all together, it's what, about 20, 25 cents now altogether? Anybody know? For a kilowatt hour? Still a pretty good deal, but our rates are some of the highest in the country. And probably if you think about all the effort that's gone into these storms and restoring power, there's just a lot of costs right there, just keeping these lines functional around here.
We're about 19 cents an hour, I
19
believe.
cents altogether?
Yes,
Yeah.
and that includes having a higher percentage of renewables.
And it was like a year and a half ago, like 30 cents. It's really varied a lot. It's come down quite a bit, so good news. If you're really interested in monitoring electricity throughout your whole house, you could invest in a whole house energy monitor. And I've got one with my house, and it's telling me right now I'm using about 170 watts, which isn't too bad. But then it also will show like the amount of consumption over a period of time, and so there's probably microwave or stove that got turned on. You see the little spikes there for a short period of time. And then what's pretty interesting, this is a Sense brand. It will, even though it's monitoring just all the electricity that's being used by the house, it uses artificial intelligence to figure out kind of the electrical signatures of specific big electricity consumers. And so it tells me, like, now I know exactly how much electricity I'm using when I'm charging my car. I have a plug-in hybrid, or my boiler circulator pump, or the clothes washer. So it's pretty neat. It certainly doesn't capture everything, but it's got a pretty decent list of devices that I can know specifically when they're on, when they're off, how much electricity they're using, by the month or year or day. So there's other devices like that as well that are pretty nifty. Yeah.
Are there any AIs that just turn everything off when it needs to?
Yeah, well, there's certainly kind of the whole smart home technology thing, and there are some that do that. One of the things that I found is a very good use for this device. It'll tell you if you have something on for a certain period of time. So if you're not expecting, something that's caught that to be on for a long period of time or off for a long period of time, it'll give you an alert. So we had, I think it was middle of September last year, where we had that hurricane that kind of just barely grazed New Hampshire, but still some power outages. And we had some circuit breakers that tripped in our house, and we were away, and one of those circuit breakers was our refrigerator. And it would have been really handy to know, that our refrigerator was off for 3 days. So now I have it set up so that, the neighbors could come over and turn that circuit breaker back on or something like that if it's off for a long period of time. So it's pretty neat, device. And there are, all sorts of kind of smart home technologies that can monitor things. To some extent turn things on and off, but a lot of it's kind of more on the monitoring side. Next slide.
Andy, I will say that there are a couple of brands of controlled receptacles that integrate with that, so you can manually turn things on and off.
That's right, yeah, that
So
you can do some
TP-Link
control
and
with.
CASA both
Yeah.
integrate in with Sense, so that there's a 6-plug power strip that if you tie it into Sense, it monitors the use on each receptacle, and you can control each receptacle individually, which is really nice.
Yeah, very cool.
Yeah.
And there are certainly other brands out there besides Sense, but they're an interesting company with
Sense is
the
lovely.
AI part.
It is?
And
Yeah, they're based in Cambridge.
Yeah, Boston area, yeah. Yeah,
There was an article in the New York Times about, we always used to methodically shut off all the lights immediately when you left a room.
Mhm.
And they did these energy calculations with LED bulbs. And, it said, well, if you leave it on for 2 hours, you'll use 0.003 cents.
yeah,
If you leave it on all day, you'll use 3 cents for the whole day.
Yeah. I mean, it
it's a lot
adds
less.
up, but yeah, if you think
It does
about
add up,
1,000 watts on for an hour is a kilowatt hour, and that's
Yeah.
20 cents or so. If you've got a 8 watt LED light bulb, it takes that
Is it that much?
light bulb
Yeah.
on for a pretty long period of time, or a lot of light bulbs to get to a kilowatt hour.
Yeah,
But it also adds up.
yeah.
And jumping the gun a little bit, but these days with the LED lighting, people used to think, well, my lights aren't going to last as long if I keep on turning them on and off.
Oh.
It doesn't make nearly as much of a difference with LED light bulbs as it was with the compact fluorescent light bulbs. So don't worry about that so much. And then I always say that, it's the people who aren't in this room virtually or physically that should be getting this message, but there's still just the good old Yankee frugality and turning things off when you're not using them. And kind of along the lines of what you're just talking about, somewhere in the order, it varies from house to house, but somewhere in the order 20-25% of the electricity that we use in a home is from what we call phantom loads. And those are things where the device is not giving you any useful service, but it's still using electricity. So whenever you see a little light somewhere, and even though you might not have that device on, it's probably using some electricity. I measured some computer speakers that the computer was off, but the computer speakers were still on, and they were just using 8 watts, just sitting there. So, the same as the LED light bulb, pretty much. So there's, things like that they're kind of hard to control. It's not like, you want to turn off your internet router when you're not using it. And there's, even things like GCFI outlets that have a little light. They're using electricity, but it's not like you want to, turn off that circuit breaker or something like that. So it's a little bit of a challenge, but I think that's kind of getting the inner energy geek coming out of you, kind of like going around the house and saying, all right, where is all this electricity getting used? And certainly that plug-in electric meter is a good way to start. All right, next slide.
Just a question. If you have light bulbs plugged in, or lights, electric lights plugged in, does it use a phantom load? If
For the
light
most
is-
part, if it's just a standard electric light, whether it's incandescent, LED, or fluorescent, it's not really going to be using any electricity. If it's a smart light, it may be using electricity.
Yes.
And there are some systems where you've got ballasts and other kind of more commercial type systems that might be using some electricity off. But for the most part, no. Good question.
Andy?
So we're just kind of talking about lighting. Yeah.
No, that light bulb we passed around, if you left it on 24 hours a day for a whole month, it'd cost $1.34.
Yeah. Yeah.
That's kind of,
What did you say?
that one light bulb we
Yeah.
passed around, if you left it on 24 hours a day for a month, it would cost $1.34.
Oh, okay,
And
yeah.
that's on.
That's at
That's
20 cents a
yeah,
kilowatt
yeah.
hour,
Mhm.
your local rate. So it's not that
21
expensive.
cents, not 19, thank you.
Yeah.
So I remember doing button ups where it's like, yeah, we're gonna, one of these days we're gonna have LED lights. It's gonna be great. It's like, yeah, so we're already there. I mean, what's happened is that these LED lights have become very inexpensive, but they're not quite as long lasting as the ones that came out 5-8 years ago that were much more expensive, but a little bit longer lasting. But these ones now, they used to be like very heavy. These ones just look like a regular old incandescent light bulb.
Can you get them with glass?
That's a good question. Possibly. You kind of get what you pay for with LED lighting. And next slide. So, I mean, the good news is that you can get like the candelabra type lights. You can get ones that are rated for outdoor usage. You can get ones, you have to be a little careful if it's like a totally enclosed fixture. You'd want to get one rated for that. But in glass, yeah, I believe so. Actually, there was some really neat LED light bulbs are ones that dim. You have to have the right dimmer for it that can handle it, but they look like an old Edison light. They'll go down to like this kind of orange glow, even though they're LEDs. So, and I'm pretty sure those are glass. They look pretty old-fashioned. Yeah, pretty neat. All right, next slide. Yeah, so these are, sometimes it's kind of hard to find this, the suitable for enclosed fixtures. You may see not suitable for enclosed fixtures, particularly with the higher, brighter light bulbs. And so those you have to be kind of careful about putting in a totally enclosed fixture because it just won't last as long. And then I tend to recommend the warm white, which is just kind of what we're used to with your standard kind of residential lighting. There are the kind of bluer lighting that's called daylight. And not that it's, a lot of people like it, but the problem is that if you start mixing those different types of light bulbs, you're just going to have, it's going to look strange.
Weird.
And so you probably want to decide, all right, this, I'm going to stick with warm white or I'm going to stick with daylight and not try to mix it too much. Next time you're driving at night, you can notice how some headlights are kind of more brown and some headlights are more sort of white to blue.
Yeah.
That daylight is that white to blue and the kind
Those
of
are the ones
yellow
that blind
is
you.
more.
Yeah.
Yeah, they tend to be brighter as well. Another factor. All right, next slide. Any other questions about lighting? So some other just kind of quick tips. This is for hot water energy saving. So whether you use a heat pump hot water heater or use oil or whatever, installing these low flow aerators and shower heads is a nice way to save not only on hot water heating costs, but also say like here in the country and you've got a well pump, you're going to save on the electrical costs of the well pump. There's a lot of places that are in the country and they have septic systems, they have a septic pump to move that wastewater to a leach field. So you'd be saving on all those things. And then just nice do-it-yourself project. I'm sure you folks, when you go around, this is probably one thing you look for is they have kind of pipe insulation.
Yeah.
And if you can, get the thicker stuff rather than the thinner stuff. And trying to cover not just piping for the domestic hot water, but also if there's any piping for the heating system. And it's a comfort thing as well. That if you have nicely insulated domestic hot water piping, it's gonna stay warmer coming out of the tap rather than, being cold and then getting warm again, things like that, as well as help save energy.
You can get this at Ocean State.
Yeah, and a lot of hardware stores and building supply stores. Sometimes it's a little hard to find the thicker materials, and you want to make sure you get the right interior diameter for the pipes that you have. There's like 1/2 inch, 5/8 inch, things like that. Turning the hot water aquastat. So this is your domestic hot water down to about 120 degrees coming out of the tap, which, if you have like a food thermometer, that's pretty easy to measure. Or if you don't, just like if you can just sort of barely stand the hot water coming out of the tap for a second or so, that's roughly around 120 degrees. And then just washing clothes in cold water rather than hot water helps save energy. Next slide. And then,
Question?
yeah.
Is there any downside to not washing clothes in hot water?
Well, some people say that. I think, for the most part, pretty much all the detergents now are designed to work in cold water pretty well. It could be for things like, bright whites or something like that. You might be able to get things a little bit more whiter, but I think for the most part, clothes washers and detergents are designed for it. And some clothes washers will have like a setting that's like not absolute cold, but sort of cold, so they mix in a little bit of hot water, so it's not like, 40-degree water that your clothes are getting washed in or something like that. Already mentioned dehumidifiers, and that's where, getting that setting so that it's not on too much, but on enough. I mean, I noticed in a lot of basements, it's big differences in dryness of basements, but I noticed in our basement, which is relatively dry, but we have a dehumidifier. I oftentimes wait until June or thereabouts before I turn it on, and then maybe sometime in September, early October would be like when I would be turning it off. Because right now, I know this might not make a lot of sense for a lot of you folks, but the dew point, which is a better measure of humidity in the air, I just checked the other day, it was 29 degrees for the dew point. In other words, this air is quite dry air, and that's the key thing. Last summer, we didn't get below like 60 degrees for a dew point for months. We just remember that rainy, wet summer, and that's where a dehumidifier comes in handy to make sure you don't get to like mold growth conditions and things like that in the basement. Energy Star appliances, and line dry clothes outside if possible. And then Energy Star appliances. Next slide. So these are some rebates that are available from New Hampshire Saves, and you can go online to the NewHampshireSaves.com website and download the rebates or find out more about the process. There's a little bit of variation in the amount of the rebates because there's kind of different levels of Energy Star, and clothes dryers in particular. There's essentially kind of heat pump style clothes dryers. What's interesting about those is that you can actually install them in a place where you don't have to vent the air to the outside. So they give you a lot more flexibility, but they're also a lot more expensive. But they're also much more efficient than your standard electric clothes dryer.
And you could use an incentive from PrEP to offset those costs.
A double incentive.
That's right.
Now, I'm not sure if there's a tax credit for things like that, but I'll mention a little bit later on tax credits that are available for some efficient devices. Refrigerators, it's a good one. If you've got an old refrigerator, certainly want to look up what's its rating, not only whether it's Energy Star or not, but how many kilowatt hours a year is it rated for. And then this is a nice feature, the program that New Hampshire Saves have, where if you have a second refrigerator or freezer, still functional, but you don't really need it any longer, they will haul it away and give you $75. This is where it's like, my electric company is giving me $75 to use less electricity. It's a cool program. Is there a PrEP incentive for that too?
No, there's not a PrEP. No, but I did want to just put in the word of trying to get rid of your refrigerator before it breaks, because the refrigerants that get released when it does break are thousands of times more potent in their greenhouse gas warming than carbon dioxide is.
Wow.
So it's really, refrigerants are a really big deal.
Yeah, that's a great point. And the nice thing is about with this program, it's with a company that specializes in this, so they're going to recycle those refrigerants rather than having them released to the atmosphere. And Phil, any update about whether that?
There's a new contractor on board.
Okay.
I'm not sure if they're picking up yet, but there was a problem with the contractor that had been doing that for the past couple of years, and it went back out to bid. And if they're not picking up yet, they will be soon.
Great. So it's just a matter of calling up Eversource and saying, I've got an old refrigerator. Another thing is that if you let that refrigerator no longer be functional, you can't participate in the program. It's only for functional refrigerators and freezers.
It's good to know.
You could pay $20 to fix it and then get 40.
Yeah, you could call up Max and
That's right.
Because typically you do pay to dispose of. If you were to take it to your local transfer station, they
Yeah.
typically charge you a white goods fee,
Yeah.
like $50. So
they'll recycle the metals and the refrigerants, but it does cost something to do that.
Yeah.
And people know about, I just learned about this from teaching the course at Max, that they have, once a month, the bring something in to fix
Yeah.
day.
Is it-
Which is, I think it's awesome.
What again?
The fixing
Repair
cafe?
The repair cafe.
Oh, yeah.
Repair
Yeah.
cafe, yeah. Yeah, so bring your refrigerator in. All right, next slide. So kind of moving away from electricity savings and domestic hot water and more kind of keeping your home warm in the winter and cool in the summer. So this is kind of a weird time of year to be talking about all that, but we do live in a climate where really our biggest expense associated with energy with our homes is heating our homes. So even this time of year, it's a good time to kind of be thinking about that. And I think if you click it again, something else might show up, yeah. So this isn't about freezing in the dark, although, I applaud people who keep their thermostats low and things like that. Next slide. And just some quick tips along these lines, turning down the thermostat, maybe using a smart thermostat, which actually has like occupancy sensors, so it can help kind of turn down that thermostat automatically for you if that works for you, or a programmable thermostat. This is definitely not the time of year to be talking about this, but in the fall, say like October and November, if you do have window air conditioners and they're going in your standard window, it's very, very difficult to get that window with the air conditioner in it to be completely sealed. So really the best way, even though it's a pain, is to take that air conditioner out and then fully close the window. And then just make sure that if you've got storm windows, that those are closed and you're latching the windows. I've done a number of blower door tests over the years, and because it measures air leakage, including things like cracked open windows, I was amazed at how many times I found in the middle of the winter, people had like windows that weren't latched, or they were a little bit cracked open and they had no idea because they were behind a curtain or something like that.
Mm-hmm.
So just kind of going through the house in November and checking all those things makes a lot of sense. Okay, and then we go into a little bit more depth with this in the full button-up slide, and a lot more depth with building science principles and building analysts, but a little bit about conductive and convective heat loss. But the idea is that in the wintertime, you've got a warm house and it's cold outside, and you want to keep that warmth in. So I'm going to talk a little bit about how do we keep that warmth in, and what are the mechanisms that are trying to have that heat escape. And it's not all about, if you can go back a bit quickly, it's not all just the arrows. Heat's not just escaping out of the top of the house, it's really escaping kind of all the way around. Okay, now next slide. So just real briefly, conduction is one mechanism for heat transfer, or think of heat loss in the wintertime, so that's through materials. And then convection, and that's the one that we kind of understand pretty well because you counteract that with insulation. The one that we don't tend to understand very well is the convection part. and that's basically heat loss from air leakage. But there are a number of houses around here, I would be safe to say, that they're losing more heat loss from air leakage than they're losing from lack of insulation. You know, there's people who are like, oh, I've got my house all insulated, I'm all good now. And my next question, you know, to somebody like that would be, so you've done a blower door test to measure air leakage? And they're like, blower door test, what's that? It's like, okay, well, you know, maybe you should go to a button-up presentation. And then radiation, you know, it's not 3 Mile Island or Seabrook. It's more basically, Great Day today is a good example. It's more the sun's radiating heat. And so we appreciate it on a day like today. It was, you know, probably frosty here this morning, or 29-degree dew point, maybe not even frosty, but below freezing. And so this is an important one in the summertime, that if you can reduce the sun's heat from kind of hitting the house, coming in windows, but even just hitting materials on the house, then you will help keep that house cooler. So it's like the shade trees or curtains or things like that. But I'm not going to talk as much about that, and more on conduction and convection. So next slide. So on the conduction side of things, we use different types of materials as insulating materials. So this is a foam board, type of foam board, extruded polystyrene, and it has an R value, which is the measure of insulation, measure of effectiveness, an R value of 5 per inch. And then there's other materials. This was in that NPR thing where I talked about little air pockets. It was like a 2-second thing. It's like, okay. But it is an important concept, and that is that there's materials like cellulose, which is basically ground up newsprint, and then there's materials like fiberglass, which is like the name sounds, it's just kind of this vat of spun fibers, where it's not the materials themselves that are insulating, it's the little air pockets that they trap that is insulating. And even really with that foam board, it's that way as well. It's the little bubbles that are trapped. And then there's some materials, this is like a high density closed cell spray foam, where the bubbles actually are gases that are more insulating than air, so they have a higher R value than some of the other types of materials. And so these are, I'm not going to go through all these things, but it kind of gives you an idea of the different R values per inch for most of these. But I do want to point out a couple here, and that is, and probably what kind of windows do we have here?
Double pane?
Double pane, you know, probably pretty high performance windows. And then we've got pretty thick wall. Anybody know what kind of insulation's in the wall? You know, probably this wall is R20 or something like that. This window right next to this wall is about R3, R3.5. So windows are great in terms of daylight. You know, they can bring a little bit of solar heat gain in the wintertime, but they're thermal weak links when it comes to the building assembly. So, you know, thermal pane is a little bit of a misnomer, or insulating windows. You know, and that's a good window. A single pane window is about R1, which is losing a lot of heat. And so that's one of the things where the window dressers program, you know, that's why I think it's a great program, because now you've got 2 layers, you're trapping some air in between those 2 layers, and there's some thickness to it. You're adding that as another layer, and so you'd be going to, you know, this is roughly about R2, R3, something like that, that you're adding to that window. And so even a real, you know, you might say, well, I've got a new house that's got these new thermal pane windows, I really don't need window dressers. You're still going to be getting quite a bit of a benefit with something like this. And then notice this one. And this is the same for bricks or stone. So if you have an old stone foundation and you're thinking, well, you know, I don't heat the basement, it's not a big deal. You're still losing a lot of heat, even in that 50-degree basement, because 8 inches of concrete or stone is a little over R1. So it's very low in terms of R value. It has a lot of thermal mass, which mass, M-A-S-S, which tends to mask the fact that it's actually very conductive in terms of heat. So one of the most effective things that can be done around here in terms of insulation is actually insulating basement walls. Because your basement is thermally connected to the rest of the house, even if you don't live down there or you don't officially heat it. Helps with things like frozen pipes and things like that as well.
Well, it's
We did that. That was one of the first things my husband did. was-
Did it make a difference?
Yeah,
Yeah.
absolutely.
All right, next slide. Any other questions about insulating materials? I've got others that I can pass around, but those are kind of some of the major ones. So these are some examples where there's, part of the problem with insulation isn't so much the materials themselves. It's more, lots of different materials can be used. It's more their install quality, or that somebody's moved it aside and never kind of pushed it back again. So there could be insufficient insulation. The left slide, incomplete, where it's basically not great where that layer is missing. And then anybody notice what's going on here?
Yep. Yeah, didn't get it done.
Yeah, so this is a vertical wall here, and they did put fiberglass insulation in this portion of the wall, but they just missed this portion of the wall. And that's more common than you might think.
Huh.
So can I get a volunteer to come up? I've got something that's not tricky or anything. I'm just going to put one hand on one square, another hand on another square. You're close by.
Yeah.
So just tell me which one is colder and which one is warmer. If there's any difference.
Okay.
And we'll pass these around.
Huh. Oh boy.
They feel the same?
This one feels a little colder.
Bob, what do you think?
This one's colder.
So we got these two discs. They look kind of similar. When you pick them up, you notice there's some difference. But basically, you want your house to be like this and not like this, because they're essentially the same temperature. But one is much more thermally conductive than the other. One is made out of aluminum, and one is essentially like kind of a foam board type material. And so what's happening is, even though they're the same temperature, when you put your hand on the aluminum one, it's sucking, it's conducting heat from your fingers. So it's that same concept as like when you walk on a tile floor as opposed to a carpeted floor.
Yeah.
Chances are that carpeted floor and that tile floor are about the same floor temperature. It's just more, there's a lot more heat conducting out of your bare feet on that tile floor. And so you want to have the house, you don't want to have the aluminum type house.
No aluminum floors?
I did a
Collects
button up.
electricity too.
Yeah, for sure. Or stone. I did a button up about a year and a half ago, not too far from here.
Oh, yeah.
And the person came up afterward and said, "Yeah, I have a stone house." And I was like, "Oh, I don't want to hear what's next." Something on the order of like 200 gallons of fuel oil every week or two in the middle of the winter.
Oh my God.
Yeah, it was pretty bad. So, yeah, do not recommend uninsulated stone houses.
So, I have a question about trailer parks, which have a lot of those aluminum.
Yeah, I mean, what's interesting is that most of the manufactured homes that are out there now actually have some pretty stringent standards about insulation levels. They're not very thick. So if you're talking about like an RV or something like that, you can get RVs that are better in the wintertime than others. But yeah, a lot of times it's kind of the function of thickness. But the good news with something like a high quality spray foam is that it has an R value, for about 1 inch of spray foam, you can get the same R value as about 2 inches of cellulose or fiberglass.
Wow.
So you can get a fair amount of R value with not a whole lot of thickness with certain types of devices or materials. But yeah, it's true that like manufactured homes, mobile homes, they're going to have thinner walls, but they also have bellies with ductwork underneath the home. And actually the weatherization assistance program does a lot of work with mobile homes, and it's amazing how much better they can get mobile homes to be in terms of keeping that heat in.
So they can use the spray foam.
They don't use the spray foam a whole lot. They use typically blown in fiberglass because it's lighter weight than the cellulose, and they fix the belly, and then oftentimes they add more in the top. It's a little bit harder for them to get more insulation in the walls themselves, but they can make a huge difference in a lot of them. All right, how about next slide? And so we were just talking about conduction, and basically think of it, like those squares of basically heat going through materials. Now we're talking about heat associated with air. And the thing that a lot of people don't realize is that there's a lot of warm air that's leaking out of a house, in a typical house in the wintertime. And if you can do a little bit of sleuthing. This is the kind of thing where volunteers could kind of help a little bit, but without a blower door to measure that air leakage, it's really hard to tell how much of that warm air is leaking out in the wintertime. As a colleague says, that's expensive air. That's air that you've paid dearly to heat, and it's just leaking out of the house. And we're basically talking about pressure differences. We're not talking about kind of covering a surface like insulation. So sometimes I have a slide that has like a inflatable raft, and it's all kind of deflated, and it's like, I'll sell you that inflatable raft for really cheap, $20. It's only got leaks in about 5% of its surface area. You want to buy that? So, it's not quite the same, your house, but it's somewhat similar in that we're basically dealing with pressure differences in the fact that as air gets more buoyant, it tends to, as the air gets warmer, it tends to be more buoyant. So it's like a hot air balloon, kind of. And so that's why it's leaking out of the top part of the house. And because that leaks out, then there's a slight pressure difference inside compared to outside. And so cold air will come in to replace it down low. And you can feel that on a cold day. If you go around, say like where the foundation meets the frame part of the house, like the sill plate area, and feel for air leaks like in the basement or in a crawl space or something like that. It's much harder to feel warm air slowly leaking out. And we're not talking about, I could feel the forced air system in this room. We're not talking about that level of a draft. It's much more subtle. And you can have the same sort of things happening in the interior of the house. So if you have a wood stove, for example, it will heat up the air around it. That air, because it's warm and more buoyant, will rise. It will tend to kind of flow around the room or even into other rooms. When it hits those windows that really aren't all that well insulating, it will actually tend to cool down. And so then you can have these convective air currents that are just happening inside the house. And you might see that also like between the first floor or second floor, or any place where you have a warmer area and a colder area. This is like the real energy geek, where other people might say, what are you doing? But you get like a little piece of tissue paper, toilet paper or something like that, and hold it up high in a doorway and hold it down low, and you'll notice like if there's a big temperature difference between the two rooms, you'll have basically warm air flowing out up high and cold air flowing in the other direction down low. So we're talking about those are all examples of convection, but the one that's really important in terms of keeping houses warm is that air leakage convection, that warm air escaping out of the house. So, and there's also another term for it called the stack effect. So where essentially the taller the stack, the stronger that convective force. The colder it is outside, the stronger the force as well. So if you have like a 3-story house and it's 0 degrees, that's going to be a much stronger force of air leakage than like a ranch style house and it's only 50 degrees outside or something like that. And in terms of priorities, here these arrows kind of do make a fair amount of sense in that the highest priority is up in the attic. And then the second highest priority is down in the basement. And then the center of the house is just not as much of a priority just because there's not as many opportunities, and also those pressure differences between inside and outside aren't as great. So next slide. And what you're seeing here might be a little bit hard to see all of these, but if you look closely, you'll notice that like this insulation looks like it's stained, and it is. It's basically, we tend to call this blown-in fiberglass, filter glass. in the sense that the insulation itself is not stopping the air leakage. It is filtering out the dust in the air that leaks up. And over the years, you can see it's a great way to sleuth your attic if you're willing, to go up and get on a mask and eye protection and things like that. But essentially, there's been air leaking out of this little hole over months and years, and that caused the insulation to get stained. This, in my opinion, is sort of like a chimney chase with that opening there is like a super highway for air leakage. 2-inch gap, that's potentially a lot of air leakage. And so a lot of these things are like where the interior wall inside the living part of the house meets that attic plane. So it's things that you won't notice just being inside the house. You have to go up to the attic to see these sort of things. Broken ducts, things like that. All right, next slide. So that's that A. So quiz question for you. A pegboard attic hatch with 16 inches of insulation. Is that a good assembly or not so good?
It's a trick question.
It's a trick question.
It's really good for air quality.
Yeah.
Lots of fresh air.
Yes.
Can you have too much insulation?
That's a good question. I mean, electricians might say you can have too much insulation if they have to crawl around in it. But I mean, it certainly reduces its effectiveness if you're adding insulation on top of an already well insulated assembly. There's basically diminishing returns with insulation. It's not a linear relationship. But as Trish knows, that I tell people that it's good to kind of think how these two different nodes in your brain, sort of the air sealing node and the insulation node. So in terms of the insulation node in your brain, 16 inches of fiberglass insulation, yeah, that sounds pretty good. But what about that other node in your brain that you might still be kind of developing?
You need all that insulation to make up for the holes.
Yeah, well, but the problem is that even with all that insulation, is that it's filter glass. It's allowing air to go through that insulation, and then on top of that, as soon as you have air going through insulation, now you don't have those little air pockets being trapped. So it actually reduces the effectiveness of insulation. So not only do you have heat loss from air leakage, you also have heat loss from the insulation not working as well. So that's those two nodes of your brain. The insulation, yeah, gotta have insulation, gotta also have good air sealing in the house. And what's the interesting thing about the New Hampshire Saves programs is that they, for many of the improvements, they will pay for 75% of the cost. For air sealing, they consider it so important, they'll pay for 100% of the cost. All right, next slide. And so we were talking about the A part. Now we're down to basement, the A, B, and C, the B part. And so there's some good opportunities as well down in the basement in terms of going after air leakage. And things like any place where you can see daylight. It's going to give you an indication that there's probably some air leakage. Any of these things that are coming in, and yeah, it might be more common than you might think. Yeah, I have an adage is that the harder it is to get to spots in the house, more likely those spots in the house are going to need some work. The far end of the crawl space that you can barely crawl into, that kind of thing. And so we were talking about the foundation and the frame part of the house. This is that kind of boundary, and there can particularly right at that foundation junction between the wood and typically concrete, that you can kind of have sort of a wavy boundary, so there can be a fair amount of air leakage all along the perimeter of the house. Next slide. And yes, fireplace, and who was it who was mentioning that you folks kind of plugged up your fireplace, and it's very subtle. It's not like you really notice it until you fix it.
Until you do it.
Yeah.
And then we really noticed there was not a breeze.
Exactly. Yeah. It's kind of a subtle breeze, but it's like you notice it after it's. And so what's happening is it's that same stack effect, convection. The warm air is just leaking out, going up the chimney. I mean, there are some situations where, in some fireplaces, where having a fire, you're actually at negative efficiency. In other words, there's more warm air going up the chimney than you're getting heat from the fire. And even in a decent fireplace, it might only be like 20% efficient. And then there's all that heat loss when you don't have a fire from an open flue. But if you have a good way to close that, then that's really helping to fix that. And there are some good retrofit flue dampers and things like that. It can seal it quite well. But a lot of the built-in ones don't work very well.
My son had a damper put in recently, and it's something I hadn't seen before. The damper cover is actually at the top of the chimney.
Yeah, there's a chain.
So that instead of having a shaft of cold air in the middle of your house, you've got something that's being protected from the cold air, at least a little bit.
Yeah, and usually it's like a chain or something like that. To open.
Exactly.
Yeah, so particularly if it's kind of a straight shot chimney, that can work pretty well. And yeah, there are things that, there's things called like chimney balloons, and there's these other devices that you can kind of friction fit in, or a weatherization contractor, if you're saying, well, we never use the fireplace, they might basically custom built something, like a plug for it. And then same sort of thing with like exterior doors as the basement windows and doors. If you can see daylight around those doors, that's probably means that you might need some weather stripping. A lot of windows really aren't that leaky, but if you have old pulley hung windows, those pulley pockets, or another good sign is that if it's a windy day and the windows start rattling, that gives you a little bit of indication.
Curtains are blowing.
Yeah, curtains are blowing. All right, next slide. And this is where people when I talk about air sealing, they're kind of like, well, I like fresh air and oxygen. But the thing is that a lot of homes just leak a lot more air than they should. I'm sure with this building, they've kind of got it all figured out about metering in the right amount of fresh air. But a lot of homes just too much fresh air, too much of a good thing. And so again, that's where you can kind of compare your house with standards with a blower door test. That it will measure how much air leakage there is with the house. Next slide. So what we like to say is seal tight and mechanically ventilate right. In other words, that doesn't mean that you should not have bathroom fans or not have a kitchen fan to deal with odors and humidity and things like that. And a lot of times, with the older houses, you're just fine with a bathroom fan. I mean, some of them are actually designed to work at a low level to provide exhaust ventilation even when you're not in the bathroom, and then a higher level when you need like that humidity removal. There's more sophisticated devices called heat recovery ventilators, energy recovery ventilators. In many cases, a house doesn't need it, but if you're building a brand new house, you might have in this building, it essentially allows to build it really, really tight, very well air sealed, and then meter in the right amount of fresh air. And then there's a heat exchanger that essentially helps to pre-warm the cold air that's coming in the wintertime. It pre-warms it with the stale air that's getting exhausted out. So that's kind of for the higher level, ultra energy efficient homes. But a lot of existing homes don't need that level. Next slide. And then keep in mind that moisture, particularly in the form of humidity, is an important consideration. So this is kind of a basket case of a basement with standing water. It's hard to tell, but there's condensation on the other side of plastic. And it's just like, don't do this. But if you do have moisture issues, standing water any time of the year in your basement, it's certainly a major consideration. And I always like to say that the sign of a good energy auditor is that they're going to pay attention to those sort of things. Because if you're making a home more air sealed and you're not changing the moisture dynamics, you could be kind of plugging up a lot of moisture. And so it's important to kind of understand all that. You're all kind of nodding your heads like situations where that's happened.
We're imagining the horrible effects.
Yeah, it's spray foam is a good example where spray foam can make, because it insulates and air seals, it can make a house much tighter than before. And if you have somebody coming in and doing spray foam without an energy audit and without kind of understanding some of these dynamics, there's certainly some not so pleasant stories out there.
Yeah.
All right, next slide. So here's another quiz for you. Antique cape. What's the biggest factor that's causing these ice dams?
The heat escaping.
Yeah.
So heat escaping through what sort of mechanism?
Convection.
Convection. Wow. Ooh, sounds highfalutin.
Yeah.
And that is the case. I mean, this house did have an attic, and it had some decent amount of insulation. You know, probably not enough. But the biggest factor, certainly a lot more heat loss from air leakage than from lack of insulation, because it simply did not have a good boundary to keep that warm air in the living space. So that warm air melted the snow on the ceiling, on the roof. And this is, I like to tell people, if you have icicles that get longer than, say, like 2 feet, you should be paying attention to that. And we've had some pretty mild winters, so that we kind of have some winters that are more ice dam winters than others. In the last couple of winters, we've been pretty fortunate. But that's giving you a clue. It's actually good information for an energy auditor to find out where you're getting those icicles and how long are they on a.
I've got another theory on this one though, Andy.
What's that?
I think those chimneys are interior. I think they go through the attic. So if there's heat loss coming off those
that
chimneys,
can be certainly a factor.
that's a heat source in the attic too.
Yeah, that can be a big factor. Yeah.
Is the,
Yeah.
is there any way, a lot of us have solar panels, and the snow, melts and comes down in a big avalanche.
Mm-hmm.
Is there anything to do about that?
From a weatherization perspective,
Yeah.
not that I can think of. I guess the good news with that is that usually the time of year when you have a lot of snow on solar panels, there isn't a lot of, you're not going to have as much solar production anyway. December, January in particular,
Yeah.
and come like mid-February onward, where that snow might be more likely to melt from a sunny day after a snowstorm. That's when things start picking up with solar PV production as well. But I tend to tell people that if you have a well-weatherized house, you should be able, and it's been constructed fairly recently to structural codes, you should be able to leave a pretty good layer of snow just on that roof. You shouldn't have to shovel your roof, and you also shouldn't get much in the way of icicles.
Well, I don't know if this is energy, but it's just scary because when it comes down all at once.
Yeah, not much you can do about that.
Yeah.
Metal roofs do that too.
Yeah.
Metal roofs do it too, whether you have
Oh, yes.
solar or not. Like I
Okay.
advise people against metal roofs just because of the snow shedding risk.
Yeah, there's safety issues
I'd
there.
much rather have
Just have to
an
run
asphalt
when
shingle
you
roof
go.
on a roof.
Well, some people build like a gable
Yeah.
so that the snow
Yeah.
doesn't come rushing
Oh,
down.
yeah.
Right.
Oh, that's
Particularly
right.
for
Yeah, that's
entrances,
right.
yeah.
Yeah.
It has to come down somewhere. And,
Yeah.
my rhododendron bush is 4 feet away from the wall because every year it gets pushed further. It's still alive though.
All right, next slide. And so this is not the way I would recommend handling this. It's more, trying to stop the heat loss rather than just melting the snow. Yeah, those are
Yeah.
salt.
How to eat your.
Wow.
I think that picture was taken around here, actually.
It's either
Unnamed building supply store.
salt or electricity. People use electric resistance.
Oh, right.
Yeah.
That's what
Yeah.
ice dams do, and
And
that's
those oftentimes will still be using electricity even when it's like 50 degrees out.
Oh, God.
yeah.
All right, next slide. So just in terms of, I've been talking about kind of the problems pretty quickly, things like first doing that air sealing and then adding, typically this blown in insulation kind of covers things really well, and that can be very effective. 12 to 16 inches of insulation is pretty much what you would expect with that fibrous material, cellulose or fiberglass. Next slide. And then this is kind of a little bit more effort, but removing any existing insulation using spray foam to kind of cover everything to air seal it, and then adding more blown-in insulation on top of that. And this is doing that air sealing around the chimney chase with fireproof materials. Next slide. And then just kind of like a plug for a doorway going up to a bulkhead that's both insulating and air sealing. Next slide. And then things like in a basement, this is spray foam with a fire barrier cover. This is spray foam in walls before adding the drywall. And then this is a material called Thermax. It's a brand. It's a particular type of foam board that is rated for exposure, at least in areas that aren't lived in. Most of these other foam boards are not rated for being left exposed, and you have to be careful about that from a fire risk perspective. When they burn, they produce a lot of nasty smoke. Not a good thing. Next slide. And then in the middle of the house, the center of the house, this is one example of a kind of a temporary chimney flue blocker. It's kind of made out of thick felt type material. This is a weather strip that can be done around those exterior doors where you might see daylight. And then kind of unusual to be able to see the chimney in the middle of the house, the center of the house, but this is air sealing around that chimney. Next slide. And then if you have, say, an older house and it doesn't have much insulation in the walls, you can dense pack, typically cellulose or fiberglass, in those walls, and that will insulate it. It'll also help air seal, because there can actually be a fair amount of air movement in exterior walls from inside to outside. And that's basically about twice the density of that loose blown cellulose that would be up in the attic. All right, next slide. So windows, we already talked about them a fair amount, but there's lots of reasons for replacing windows. But in terms of like cost effectiveness, for probably about half the cost of replacing all your windows in the house, you could get a really good weatherization job. It'd be even less with the incentives from PREP and from New Hampshire Saves. And you'll save a lot more energy from that weatherization job than saving from the window work. Now, you might want to have new windows for other reasons, but cost-effective energy savings isn't a really good justification for windows. Even though there's a lot of window salespeople who've kind of convinced us otherwise.
Even with pretty old houses with pretty old windows?
Yeah, there's a comfort factor as well if it's like old windows and they're not functioning very well or things like that. But one of the things that people don't realize is when they replace their old windows with these newer windows that have the low E film, they're going to get less solar gain in the wintertime because there's less of the sunlight is reaching the inside with the newer windows. So you're changing the dynamics of the house in many ways for good, but it could be 500, 800, maybe more than that to replace one window, and that goes a long way towards weatherization type work.
We did some math on this a couple of years ago, just trying to sharpen our pencil for New Hampshire Saves programs, and looked at going from the worst case single pane windows to the best case, like you 0.2 factor windows, which is R5, and even the energy savings alone, I think it would have taken 20 to 25 years to pay for the cost of a window. It's a long payback period.
The difference between those and window dressers is that this is volunteer labor. It's kind of more of a community effort, and these things average about $50 net cost. And then there's also building some for people who otherwise couldn't afford it. So it's kind of more of that barn raising aspect.
Yeah.
All right, next slide. So just pretty quickly, I know we kind of want to get through here, but it is really helpful getting that comprehensive energy audit where they're going to spend a couple hours at the house, do all these diagnostic tests, give you a report, prioritize potential improvements. In some cases, they might do energy modeling where they can kind of tell you this improvement will save this amount of energy, things like that. That's kind of a little bit higher level, but it can be done. Next slide. And so this is what a blower door is. It's basically a big exhaust fan that goes into a portable frame. and essentially it's depressurizing the house to a certain level, negative 50 pascals. And then the number that you get from it is CFM 50, cubic feet per minute of air blowing through that fan at that 50 pascals standard pressure difference. So you can do an apples to apples comparison of different houses. You have to also take into account the volume of the house, but it's relatively easy to do. And it's also used by weatherization installers to do what's called blower door guided air sealing. Well, they'll use them to figure out, okay, where do we need to, target our efforts. Next slide. Oh, and just if you go back. So blower door tests, even with the existing energy code, blower door, they've been required for a while, are required for new homes. There's not a widely enforced provision in the energy code. So something to ask how that's going here in Peterborough. We'll leave it at that.
It's enforced.
Oh, right.
New builds.
Yeah, that's great.
How expensive
Yeah.
are blower door tests?
Yeah, so if it was just done alone, like say a builder wanted a blower door test for a house, might be like $200, $250, something like that. If it was part of an energy audit that would be more comprehensive, probably more like $500 or so. And then they might do other tests as well. So they might use an infrared camera. And what you're seeing here is like this wall that's uninsulated showing up as purple. This one cavity here is less insulated than the other cavity, so it's more purple. And this is with a blower door going. You can combine the two and learn about things like, is there air leakage in the walls, that kind of stuff. So yeah, the nice thing is that it just takes a fair amount of money just for somebody to come out and set up a test. But if they're going to be there, they might as well do the whole energy audit and do things like this as well. Next slide. And then just keep in mind that, particularly for your combustion-based heating systems, you want to keep them cleaned and tuned, particularly like heating oil. It's relatively dirty, so having the system cleaned and tuned up every year is a good idea. And if you have a furnace-based system, an air-based system, cleaning or replacing the filters a couple times over the winter season. And we'll talk a little bit about more efficient energy replacements. But next slide. So one thing to kind of think about in the big picture, we talked about windows versus weatherization. A lot of times there's kind of this fixation on equipment of like, okay, I need to get a more efficient heating system. That's going to make my house more efficient. Well, it's sort of like saying, I need to get a more efficient bucket, and I'm not really paying attention to, the features of this bucket. So it's like, really kind of, in my opinion, focus on that leaky bucket first, and then you can kind of move to, you won't need as big a heating system, you won't need as big of a solar array as well. So reduce then produce is another way to think about it. Or go after the envelope and then go after the heating system. Next slide. So in terms of the programs that are out there from New Hampshire Saves, it's all 4 utilities getting together, so it's pretty consistent amongst the utilities. There's a few differences. I'm not going to go into detail about a lot of these, but there are rebates available for things like heat pumps, and there's those rebates that you saw for Energy Star appliances. The one that I'm going to emphasize is the Home Energy Performance Program. And next slide. And so for lots of different devices, there are both incentives available from New Hampshire Saves, and then IRA stands for the Inflation Reduction Act. So I'm not sure people realize that you can get a 30% tax credit for a new energy efficient wood stove or pellet stove. And that includes the installation cost. So nice sort of feature. There's also incentives both from New Hampshire Saves and the IRA for that heat pump hot water heater that we were talking about. So going to newhampshiresaves.com kind of helps to see, all the different appliance rebates and other incentives that are out there. Next slide. And just real quickly, a heat pump is a little different than, another type of heater in that it uses the refrigeration cycle to essentially move heat. It concentrates heat on a cold day and moves it inside. And it does the same thing in the summertime by moving heat from a warm house outside to cool it. So it's essentially just that refrigeration cycle working in reverse. winter versus the summertime. Next slide. And it's not a huge incentive that New Hampshire Saves offers for these cold climate mini split heat pumps, but it's a decent amount. And then some of these probably aren't as relevant, but there's a nice incentive for those heat pump hot water heaters in addition to the tax credit, which is a 30% tax credit. So it kind of adds up. And then if you do get like heat pumps, you can get incentives for the smart thermostats as well. And if you're participating in that home energy performance program that I'm going to mention in just a second, you can also get, I think Eversource has 0 interest financing for getting these other efficient heating equipment and cooling equipment.
That's good to know.
All right, next slide.
Question about the smart thermostats.
Uh-huh.
Do we have to have heat pump to get that?
Yeah, so you can't, well, there's some programs it's no longer, okay. There used to be a program where you could, but
Oh, for
you pretty much
the
need,
incentive?
well, yeah,
Sorry.
or if you have oil or propane heat, is there any,
Yeah.
are there any incentives?
So
for-
there are smart thermostats that are in the HEP program that work with fossil fuel heating systems.
Okay, so that could still be.
That could be, yeah, that's part of the program. That's one of those that we pay 100% of, so.
Yeah, so, yes. I
So that would be good.
learned something new there with that. So that's not just having a heat pump, but with an oil system or something like that.
I don't think there's a standalone incentive on those though.
Okay,
The gas,
think there's
the gas
incentive if you-
utilities do, the electric utilities do
yeah,
not.
okay, yeah, it gets a
Well,
little.
the electric utilities don't.
Well, yeah.
I just also wanted to mention in the IRA that there are rebate programs. Are we
Yeah.
to mention that?
I've got a couple of slides. I know we're kind of getting a little after 8, so we'll have to see whether we want to cover that or not. They're in the PDF of the slides. But let's go, let's see, this is the most important one of kind of the things that I'm talking about for you folks with existing homes. It's called Home Energy Performance. And if you qualify, and I'll show you how you qualify, you get a $500 energy audit for $100 up front, but $100 becomes a credit towards any work that's done. And this is the program where New Hampshire Saves Utility will pay for 75% of the eligible weatherization work, up to a total contribution of $6,000. And they provide that 0 interest financing for your contribution. So it's a pretty nice program. Yeah.
If your income's low enough, don't they pay 100%?
Yeah, so that's a totally different program. So this is called Home Energy Performance. There's Home Energy Assistance, and that basically is very much tied in with the Weatherization Assistance Program, which is federally funded. And so that is administered more by the community action agencies. So here, you're still in
Southern.
Hillsborough County, so it's Southern New Hampshire Services. A little further west, it's
Southwestern
Southwestern Community Services out of Keene. So yeah, if you know somebody who, like for example, if they're getting any sort of heating or electricity assistance, then they typically can also qualify for
Fuel assistance.
home energy assistance and
And if I can plug that program, if you know of somebody who's income qualified and getting either fuel assistance or electric assistance and they want to go through that program, have them contact the utility because we will fund 100%
yeah,
of
work
it.
closely.
So that when they use federal WAP funds, they have to prioritize service, but we can use 100% of our funds and just tell them to do it now.
And there's basically,
So that's through Eversource.
It's through, each utility has,
Yeah.
administers their own.
and there's
HVA
oftentimes more money that they can contribute
Yes.
beyond $6,000 for that weatherization work. And they can also help with health and safety improvements or even helping with getting a house ready to weatherize. And that's all with the income qualified program. So next slide. So the way you find out if you qualify, you go to the NewHampshireSaves.com. There's energy audits and weatherization section, and there's a little test your home box. And you need to know the square footage of your home, and then how much heating fuels you're using over the course of a year. It's helpful to have a couple years of information, but you can do this with even kind of estimated numbers to at least start with. And then also your zip code and your utility, electric utility. So next slide. So this is an example, a little bit hard to read, but this is a home in Laconia, 2,000 square feet, that's using 800 gallons of heating oil, 2 full quarts of wood. And basically you get a score, it's called the Home Heating Index. And in this case, that score is 9.04. And at least with Eversource, they have kind of the easiest way to qualify. It's either a score, I mean, it is a score of 7 or higher, which the lower the score, the more likely a home is going to qualify. So that's good news for you folks. And then the other interesting thing is that even if your home doesn't qualify, let's say you score 6.5 rather than a 7, then you can still participate in what's called Home Energy Performance Lite. And it's a little bit different program. It's still kind of getting rolled out, but from what I hear is that a lot of times you can still get a lot of weatherization improvements in the same sort of incentive in structure. So that's good news. It used to be very frustrating for people who were, purposely kept the thermostat down low, things like that. And now there's kind of an option for those people. Yeah.
Just a question about that HEP light, that my house qualified for that, but the only way to take advantage of it is to allow them to install a programmable thermostat in your house, which I already have.
That's not true.
No?
We can
Talk with
talk about
Okay,
that
good,
after.
because that's what it
get on
said.
that.
Okay, work it out for you.
The program has changed. If that was
Okay.
last year,
That was,
yes.
it was on the New Hampshire Saves site.
it's evolved.
Yeah.
Okay, good.
This is kind of new for
Excellent.
2024, and
That
it's a little
was
bit
crazy.
more flexible and
Okay,
capable than, what was it? It
Thank
was
you.
the visual audits was last year.
The long and the short of it is that the
Visual
new modeling software we have is much more capable of calculating savings on homes with lower energy use. So if there's measures that are still cost effective, we will still offer the 75% incentive on those things. So we'll still do 100% of the cost for any air sealing measures that are installed and things like that. It's just that the fuel usage, as it drops off, there's less that becomes cost effective, but we'll still do most of it.
Thank
And
you.
that's where having Phil as a person to kind of figure that all out.
Yeah,
It's encouraging.
yeah, it's we're trying to make that work better. So.
Good, thank you.
Thank you.
Thanks.
All right, next slide. So that's definitely if you've got a home where you're like, all this stuff sounds like something might be good at our house. Getting that energy audit, it's only $100 up front, and then you don't have to do all the things that they recommend. There might be some things that need to be done, but it's a great program. So might be a little hard to read, but this is an example of a home. This is from a couple years ago, but over $10,000 of work. It maxed out that $6,000 contribution. The air sealing they paid for 100%. They paid $4,000, and they got a lot of weatherization work for that, a little over $4,000. All right, next slide. Get pretty close to the end here. So this is the slide about the community action agencies and the weatherization assistance program and the home energy assistance program. So one easy way to find out is just to dial the 211, which is kind of connects the social service agencies. All right, so we've got a little decision point here. Lots of good questions. So even with this abbreviated presentation, it still kind of went a little longer than I was expecting. But next slide. I've got 3 slides about the Inflation Reduction Act and the tax credits and the rebates that are coming up. Y'all still want to kind of bend your ear for a little bit longer, or?
And we started a bit late too because of technical difficulties.
Oh, that's
Yes,
right. Yeah,
yes.
that was a factor. Yeah.
Yes.
Okay, so if you're feeling okay, I'm ready to keep on going for a couple more slides here. So this is trying to be pretty brief. There's already in existence this tax credit. So this would be you claim it for next year. Say you go through the Home Energy Performance Program and you get work done, you can claim a 30% tax credit up to $1,200 for that weatherization work, in addition to the incentives that you're getting from New Hampshire Saves, in addition to the incentives that you're getting from PREP. I've had questions about, and I don't know the answer completely, is that the total cost of the work or the net cost? That's something to be figured out. It
Consult
might
your
be
tax
just the net
professional.
cost. What's that?
Consult your tax professional.
Yes, that's right. Talk to the tax accountant. But same thing, I mentioned the 30% tax credit for wood stoves and pellet stoves and boilers as well. Heat pumps, there's that 30% tax credit, and that includes a hot water heat pump, hot water heaters. So this is the maximum amount that you can get. 30% of the cost up to these maximum amounts. But that's a really nice feature. You get that 30% tax credit for a heat pump hot water heater plus $750 from New Hampshire Saves. And it's a much more efficient way of heating hot water than oil or propane or electric resistant heat.
And this is per year, right?
Yeah, so you could claim, you could do heat pump this year and something else next year, because there's kind of like total max as well. I'm not giving you all the details here. But next slide. So that's the tax credits, and then there's these 2 home energy rebate programs that are coming down the pipe. Kind of big news that state of New Hampshire submitted their application for these here rebates just last week. So things are moving along with this. Who knows when it's going to be in place for you to participate in it. But this is in addition to the tax credits. So you can have the tax credits plus get these rebates. And these rebates are income eligible. So AMI stands for
Area median income.
Yeah, some people know it better than I do.
Some of us wrote grants.
And are versed in it.
So roughly speaking, a family of 4 at 150% of area median income, it's around $180,000. So family 2, it would be a smaller number, but it covers a lot of people. And then so the rebate's even higher if a household is under 80% of that area median income. And so these are the maximum rebate amounts, but it's particularly relevant for getting heat pumps, much bigger incentive coming this way than coming from Eversource, but that will be on top of it. And then if you go back, let's just say you've got a good, efficient,
Do you want me to
go back a slide. So then you can get the tax credit, you can get the HERE rebate, and you can get a New Hampshire Saves rebate and get a prep incentive as well, maybe. If there's any more money that's needed, for that nice package.
This has been our nightmare.
Oh, okay. Yeah, it is pretty complicated.
We're not allowed to, we can't stack it.
Oh, with
Because
other
they're both
federal.
federal,
Yeah.
Oh,
That is going to be a little tricky.
But you could get both the New Hampshire rebate and the IRA rebate, for example, for a heat
And
pump
the
water
tax
heater.
And the
And the
tax
tax
credit.
credit,
So,
yeah.
yeah,
And the tax
anybody in
credit
New
goes with
Hampshire-
anything.
Yeah.
But I wasn't sure whether New Hampshire was gonna be replacing theirs with the IRA or letting you add the money.
Yeah, and that's relevant for 2 slides, or the next slide after this one, where it's very similar to home energy performance, the HOMES program. So you can do either the HERE program or the HOMES program as a rebate program, and either one of those you can stack the tax credits on top of it and stack New Hampshire Saves, but you can't do the HERE program and the HOMES program. So next slide. And the HOMES program, like I said, is very similar to the HEP program with New Hampshire Saves. And so it's based on the amount of savings, total savings with the home. It's not based on specific devices like a heat pump or induction range or whatever. And most likely, I think the direction that the state of New Hampshire is going to go in is modeled energy savings. So that fits in very well with what's already happening with the home energy performance program. And so if you can get at least 20% modeled energy savings, then you can get these rebates. And this one is under 80% a higher rebate, and then it basically has no cap in terms of income at the higher level. So yeah, it's all very complicated.
Wow.
Yeah.
It is.
So Lakes Region Community College, we're going to be training professionals associated with these programs. I think one of our key trainings is communicating about all these programs.
Yeah.
Just the basics.
Yeah.
And
Provided that they don't change so much.
yeah, I think
Yeah.
once they're kind of in place, they're going to be in place. And the good news with the Inflation Reduction Act, unless Congress changes things, is that it's going to last until I think 2030 or so.
Oh,
2032.
20,
Yeah, so some
10
programs
years.
not going long, but it's going to go into the 2030s. So it's not going to be just here and gone kind of thing. So, and that's pretty much it, I think. What's the next slide? Yeah, that's a summary, and next slide is my contact information. Oh, no, this is a slide about how to get a hold of slides from Paray, and then here's my contact information. So I both do kind of consulting as well as work with Lake Station Community College. I don't do energy audits or specifically involved with these programs, so kind of vendor neutral in terms of the folks to work with or whatever. Thank you very much.
Thank you.
Oh.
Thank you.